Hey y'all, it's me, Miss B. Today we're going to be talking about how to find the domain of composite functions. But first, let's go over what a composite function is. So, a composite function is the nesting of two or more functions into a single new function. So, I'm going to give an example of this over here. If we have, let's say, f of x equals 2x, and g of x equals 3x plus 2, a composite function would be like f of g of x, in which you would plug in to f of x, wherever there's an x, you would plug in g of x. So we get that f of g of x is equal to 6x plus 4, simplified. Okay, so that is our single new function. Now, we do ask ourselves two questions when we are determining the restrictions on the domain, which is what we are focusing on today. Go ahead and answer, what are those two questions? You should have put, is there a fraction, and is there an even root? Okay, so next up, we need to walk through the steps for finding the domain of the composite function. So if we have our composite function f of g of x, then first we want to find the domain on g of x, that inside function. So this is domain of the inside function. Next up, we want to plug g of x into f of x and find the domain. So find the composite function and its domain. Then we want to simplify our domain. So we need to combine the domains together. Then finally, we want to write the answer in interval notation, which you have practiced before. All right, so for g of f of x, so these steps are for f of g of x, but for g of f of x, it's basically switched. Also, note our functions might not be labeled as f of x and g of x, but the steps are going to be the exact same. Okay, so looking at our examples, it says find the domain of f of g of x and g of f of x for each of the following functions. So here's our first part. We want to find the domain of f of g of x. So step one, what we need to do is find the domain of the inside function. I took the liberty of writing the inside function over here. So we're going to ask ourselves our two questions. Is there a fraction? And is there an even root? You should have said, yes, there is a fraction. So we set the denominator, x plus 2 not equal to 0, and solve. So x is not equal to negative 2. There is no even root, so we don't have to do that. Next up, we're going to plug g of x into f of x. So I'm going to go ahead and color code this so we can see f of x is our outer function. To change this. Oof. So f of x is equal to 2 over x plus 3. And then g of x is equal to 5 over x plus 2. So as you can see, we plugged in that g of x in for x in the f of x function. All right. For all intents and purposes, we don't really need to simplify this. For the time being. Later you might have to. Okay, so then we're finding the domain of the function f of g of x. So I asked myself two questions. Is there a fraction? Is there an even root? So we do have a fraction, yes, so we're going to set the denominator equal to 0. All right, so I'm going to walk through this here. Go ahead and subtract 3 from both sides. We get 5 over x plus 2 is not equal to negative 3. Stick that over 1 so that we can cross multiply to get 5 does not equal negative 3 times x plus 2. So 5 does not equal negative 3x plus, minus 6. Add 6 to both sides, 11, negative 3x. So then finally we get x is not equal to negative 11 over 3. Let me rewrite that a little bit neater. Negative 11 over 3. All right, so that right there is our restriction on the domain for that. And then we have to ask ourselves, is there an even root? The answer is no. So we don't have to do that. Step 4 is we want to combine our domains. Were there 5 steps or 4 steps? I can't remember how I did that. Yes, this is like kind of step 2 and step 3 all in one. So we want to simplify our domains. So we want to combine these two things. So we have x is not equal to negative 2 and x is not equal to negative 11 over 3. You can put that on the number line. That's not right. It should be the other way around. Negative 11 over 3 is on the left, negative 2. So when we graph, we have an open circle on both, but everything else, it gets filled in. So then when we put this into interval notation, we get negative infinity to negative 11 over 3, negative 11 over 3 to negative 2, and negative 2 to infinity. And that right there is our answer. All right, moving on here, we're going to find the domain of g of f of x. So first, go ahead and find the domain of the inside function. Now, what you should have put for that is, you say, is there a fraction? Is there an even root? Yes, there's a fraction. No, there's not an even root. So we'll show the work for a fraction. Set the denominator not equal to, not equal to 0. So x is not equal to negative 3. Next, we plug f of x into g of x. I'm going to have to look up here to see what that is. G of x is 5 over x plus 2. So we get 5 over x plus 2, and we plug f of x in for that. So that is 2 over x plus 3. Again, you don't need to simplify, but we do need to find that domain. So we ask, is there a fraction? Is there an even root? Yes, there is a fraction, so we want to set the denominator not equal to 0. So go ahead and solve for that. What you should have done is moved that 2 over, so you get 2 over x plus 3 is not equal to negative 2. Put that over 1 and cross multiply. So 2 is not equal to negative 2 times x plus 3. 2 is not equal to negative 2x minus 6. 8 is not equal to negative 2x, so then x does not equal negative 4 for that second part there. So then finally we want to combine our two answers. Again, we have that x does not equal negative 3 and x does not equal negative 4. We get open circles on both of those, and everything else gets included. Oop, that's fine. So then our interval is negative infinity to negative 4, negative 4, negative 3, and negative 3 to infinity. That right there is our answer. All right, so we're going to just stick with one example for the sake of time. If you want to try that next example, I think that'd be a great idea.